Hey YouTube, 3D Printed Life here. Now if you saw my video earlier today, or yesterday, depending on when you're watching this, you're probably like, so, 3D Printed Life, did you find a solution to your problem? Yes, I did. Thank you to everybody who helped. Basically what I did was a combination of a few suggestions. I'm sure somebody did suggest this directly, but I might not have interpreted it that way. But basically what I did is I 3D printed this little adapter collar. Now this sits inside of the flanged idler, and basically what it does is it reduces the bolts needed from an M5 to an M3, but also this is a little bit bigger, so when you tighten down the bolt, it puts pressure on this centerpiece instead of on the idler directly, and as a result, it can be snug in there and yet still rotate freely. Woo! Now you're probably also wondering, what is this magnificent piece of metal that you're mounting this thing onto? And this, and this, and this, and this. Yes! The metal parts finally came in. I'm so excited. And honestly, I was going to do a build vlog, step by step putting this guy together, but it went together so quickly, I really just didn't have a chance to. Basically, this is the result of maybe an hour of building, and then a bit more time making custom parts and things like that. But the majority of it was spent picking up little ball bearings. So what happened is I built this little gantry, and originally I didn't have these bolts sticking out here, so there's nothing holding them on the back, and I didn't have the motors in yet, so when I went to tip up this guy, it slid back and, oh, slide, whatever, you get the point. This slid back, off the rails, balls went everywhere, it was a nightmare. So you're probably like, well, it's on there now. Yeah, my family helped me find all of the balls, well, most of them. Each of these is probably about 5 to 6 balls short, but it's enough to work, so I'll be using them for the time being until I can get new linear guides, but hopefully it should at least just provide enough, friction resistance to work for a little while. But yeah, so parts, let's talk about them. So there are a total of 5 machined parts that I just got. So now all these parts are from Parts Badger. If you want to get your own parts machined from them, check out a link below. I will be doing a bunch of videos in collaboration with them in the future. They were just delayed by some behind the scenes stuff, but once all that is sorted out, I'll be releasing those videos. There's about 4 or 5 of them, so they should be pretty good. But let's talk about the parts we have here right now. Now the lighting's not the best, I apologize about that actually. That's a little bit better, since we don't need to see any extreme detail. So there are 5 main parts. Let's start with the bottom. This is a base plate, a 16th-inch aluminum plate, anodized black, of course, like everything else. Basically, this just acts as a base plate to make the printer look pretty, to hide all the electronics, and to mount the Z-axis stepper motor to. Now, these other 2 bolts are just some reinforcement brackets there, as you can see, which are corner brackets that aren't actually in the corner. They're just basically there to act as reinforcement around the motor. Next is the Z gantry, which is thicker than before. Yes, it's 50% thicker, which should hopefully mean about half as much flex. And I mean, as you can see, even without the top rods in, it's pretty rigid in there. So yeah, definitely much better. When the top's on, of course, even better. Much better than the Eclips3D. There's still a tiny bit of give, but that's really unavoidable with a cantilever design like this. But the benefits of the cantilevered bed are a much cheaper printer, and in most cases more accurate layers, smoother layers, and no Z-banding and so forth. Now let's move over here. Let me turn this light back on, and we can talk about these 3 parts. Now the first one's the big one. This is the top plate where everything mounts to. It is an awesome part in my opinion. And basically everything just bolts straight to here to make it for a super easy assembly. I mean, like I said, I built this up, this Core XY stage. If I didn't have any issues and like I actually was following directions that I don't have yet but will have, you could do it in like half an hour. It's super simple, super easy. And that should make for not only a simple 3D printer, but also a high precision one, because everything's just bolt on and should work. So corners, we've got holes to bolt straight to the top of these extrusions. Then we have slots, which will be for the panels when those come in. I'll be getting those later on. Didn't order them yet. I'm waiting until the design is final. We also have, of course, holes for mounting these linear rails along here on both sides. We've got holes for mounting the pulleys, and you'll notice there are some extra holes because my solution here, again, I said it used an M3 bolt instead of an M5. These are M5 tapped holes, so what do you have to do? Well, I had to make new ones. But basically, I just shifted this side forward and this side back. Shifting this forward and back really shouldn't affect anything other than the length of belts needed, so really shouldn't see any issues there. And now I can actually finally assemble this printer, which means this guy will be printing in just another like 1 or 2 hours of work, which is insane. I can't wait. Moving on to the back here, we've got the stepper motors on standoffs. Now the one thing I don't like is how high this pulley is on the stepper motor shaft. I was considering somehow having like another cylinder that will come out the top of this and go into a bearing that's in there. So that will be sorted out later on. But as of now, I'm just going to leave it as it is. I don't think it should cause any super major problems for the time being. I mean, the belt for 3D printers isn't under a huge amount of tension. It's really just enough to keep the slack out of it. So I don't think it's going to be enough force to really bend the shaft or have any major effect there. But of course, the mechanical engineer inside me is still screaming at me, saying I got to fix it. So I will see what I can do with that. These are the tops of the rod mounts, of course. They just bolt straight in here, and then you can tighten them in. So it also makes for a super easy removal of this top gantry, because you undo the 4 corner bolts, you undo the 2 rods, and the entire top, the entire Cork's Y stage will just lift straight off. Nothing else attached, so that's pretty awesome, especially for like troubleshooting and stuff like that. The motor is also a cool thing. The wires, since they're at an angle, their wires are pointing sideways and back, which means hiding them should be super easy. They'll just basically come back and then down. Well, up is down, down is up. You get the point. Yeah, and then also I got to put some more idlers in here. I forgot about these idlers, which guided around these posts, so I'm going to have to, I guess, drill more holes there, I suppose. I don't know what else I can do. Unfortunately, these are in a very tight space. I didn't really think of that. Hopefully I am able to get some extra holes in there and fit the idler pulleys in. But if not, I will work something out. I always do. Move on over to here. This is the Y gantry plate. It's an 1/8 inch aluminum. Oh yeah, this guy's a 1/4 inch aluminum, by the way. So this Y gantry plate is an 1/8 inch. Basically just attaches to these 2 sliders, and it attaches the Y gantry rail on that side. There you go. So other than that, it's just got 4 idlers. So it's going to have 2 smooth idlers on the back side and 2 toothed ones on the front side. So of course I still got to put those toothed ones on with those modifications that I made, but those will be going on the front side, and then that will be the completion of the belt guidance system. So now let's flip this guy over to the top side, and here you can see the actual extruder piece. Now this piece is very funky designed, and as I mentioned in the full design overview, that's to support dual extrusion out of the box, hopefully. I don't think I'll be fully testing it, but I will design, at the very least, design the part that will drop in here for the Chimera hot end. So basically anybody who has access to a CNC, or maybe I will have them CNC'd in bulk and sell them. Don't really know yet. Point is, it should be fairly easy to get dual extrusion. You could probably even just 3D print that bracket for the time being to test it out, or I might do that. I don't know. Anyway, these top bolts are a little bit funky looking because I didn't have the right size. In fact, these are countersunk bolts that are going in here. So everything here is going to be flush, which is going to be nice, but I didn't have them, so, you know. But that top plate's pretty simple. It's basically just mounting the hot end, which is right there, and bolting onto the carriage for the x-axis, and then it's going to hold this little belt thing, which this is an old design. I'm not going to be using this in the final one, but that's all I have for right now, so it's what I will be using to test. I will just somehow zip tie the belts to it in order to secure them in place. That's not really all that important, but what is important is that the printer is coming together. So when do I expect to have it printing? Well, very, very, very soon. I can't give an exact time or date, but I wouldn't be surprised to see it printing tomorrow, at least moving tomorrow. Printing would be awesome though. So yes, definitely stay tuned for that. I will keep you updated as I complete those little idler pulley installs. For these two, they are through holes, so that should be pretty easy. And I just got to, I guess, drill and tap those 2 more that I missed, and then I should be good to go. So that's pretty much it. Let me just actually throw this on for you guys real quick. So now this isn't bolted in place. As you can see, this guy's a little off, but it should give you an idea of what the printer's going to look like, and it's pretty awesome.